I hope everybody is enjoying week 10. Almost the end of the term. In fact, this is our last Monday tutorial together. Can you believe it? I can't believe it. I'm super sad. But I'm also happy that the term is ending and you're moving on and doing all that sort of stuff. All right, so in today's tutorial, I thought we could look at improper integrals. Okay, so in this tutorial last week, we did a lot of algebra. So I thought I'd balance that up with a bit of calculus today. Okay, and so I thought we could work through, you know, some of these problems where you've got the improper integrals from section 8. Okay, they're important problems, and you might see them in the final exam. Okay, but no guarantees. All right. So the idea with improper integrals is that we want to see whether they converge or they diverge. And you know, this little infinity sign can be interpreted as a special limit. So let's work through these, and we can you know, just unpack them and discuss them as we go. So I thought we could talk about f first. F's an interesting one, and then we'll move on to other ones. So we've got the improper integral between e and infinity of x on log x. So let's do that one, and then we can move on to something else. Oh, and I don't have my document camera ready. Just give me a second. All right, so there we go. All right, so this is 19, part F. All right, so this is the kind of question that we're faced with. The way that we can relate this to regular Riemann integrals is through a limit. So I just use the letter B. Okay, so what's standard about this is that you do the antiderivative and this Riemann integral first, and then finally you take the limit and you see, well, does the limit exist? If it does, then this original integral converges. If the limit doesn't exist, or it goes off to positive infinity or something like that, then we say the integral diverges. Okay, so for this one, who can suggest a strategy for performing this integral? Can anyone suggest a strategy on the chat? If you were given this problem, how would you do it? Okay, let me know on the chat. How would you do this integral? What might a strategy be? Who can tell me? Oh, integration by parts is an interesting idea, Abdul Rahman. That's one strategy. Yes, but what's the Abdul Rahman? What's the integral of 1 on log x? That's pretty hard to do, I think. So the way I would do it using a substitution. So let me just write it out a bit more, and you can see where it's coming from. So you've got this, you've got 1 on x times 1 on log x dx. Okay, so can you see a relationship between logarithm x and its derivative? It's right there. Okay, so that's something to keep in mind, and we'll use a substitution. So du equals 1 on x dx. And so you can see there and there, that's 1 on x dx. So you can replace that with u. All right, so all we need to do now is worry about the limits of integration, right? Yeah, actually, you know what? I can actually just go straight from here to here, okay? So what I'll do is I'll let that go in there, all right? And so as x goes to infinity, u also goes to infinity, right? When x equals e, u equals 1. So let's rewrite this original integral. This is interesting, but let's just rewrite the initial integral as this. 1. That takes care of those two bits, and I'll get 1 on u du. Okay, so it's taken me a little while, but let's write this in sort of this form now, and we'll do it the normal way. Okay. Now this looks good because this is easy to integrate. Okay. You do the inside integration first. So 1 on u will become log u. Okay, so by the fundamental theorem of calculus, you can put in b and 1, and the last thing is to take the limit. Okay, so the natural logarithm of 1 is 0, but here's the problem. This goes off to positive infinity. Okay, so what can you say? The integral diverges. To positive infinity. Okay, now technically speaking, you didn't need this. I just wanted to show you the relationship between, you know, this sort of notation and this sort of notation. You don't have to write this down. You could go straight from there to there. Okay, questions, people. What questions do you have? Let me know. We got 25 people here. Let me know. All right, well, if there's no questions for that one, let us move on to the next page. And you might remember from lectures from last week, then there's a couple of tests that we can use to see whether an integral converges or diverges, okay? There's the comparison test where you use inequalities, and then there's a limit form of the comparison test. So let's talk about those, and we can go through them together, okay? All right, so let me share my PDF with you. So I thought we could have a look here. Use the inequality form of the comparison test to work out convergence or divergence. The first one has a video, so I won't do that. I'll do the second one. Okay, so just as a guess, who thinks the second one convert. Oh, actually, let me put a poll up. Let me put a poll up. Okay, so 22B converges. So I'm going to ask a question here. 22B converges. Is it yes or no? Okay, I want everyone to have a go at this one. Todd, what do you think? What does that tasty burger of yours think? Does this integral converge or diverge? What do you think? Just have a guess if you don't know. Okay. Take a guess if you don't know. Okay, so we're still waiting for 9 people to respond. Carl, what do you think? Oliver, Ashvin, what do you think? Yes, no, maybe. Mengda, what about you? Li Xiang, what about you? It's our last tutorial together. Let's have a go. Okay, well, almost everybody has voted now. Let's show the responses. So 7 people said yes, 14 people said no, and 4 people are asleep. Okay, so let's have a look. Let's have a look. So the thing I look at is there's a cubic root and there's a power 2 there. Okay, and this extra bit over here, this is not going to affect the integral much when x is large because the x squared is going to dominate. Okay, so it's like 1 on x to the power 2/3. Okay, so that's what I'm going to keep in mind here. So let's go back to our Chrome tab and we can make some notes. So this is 22b. All right, so I'm going to let I be this integral. Okay, so this x is not going to make a big difference. The x squared and the cubic root is going to make a difference. So okay, so this kind of behaves like this, really, for large x. Okay, and so this second integral diverges because it's a divergent p integral, right? P equals a 2/3, which is less than or equal to 1. So that kind of tells us, well, we think that this is also going to diverge. But let's actually use the comparison test. Okay, so this is just some initial thoughts, and let's actually see. Okay, so this is like, well, we think this is going to diverge. Let's see if we can actually prove it or show that it does. Okay. All right. So I'm sure that you'll agree with this, right? Okay, the cubic root of that is less than or equal to that, which equals that. So this is going to be my p, similar to my p function. So if I divide, I'll get this. Okay, so now when I integrate that, I get that. That's going to go off to infinity, and that is also going to get pushed off to infinity. Okay, that is a divergent p integral. So this goes to positive infinity. It's got to push that one off to positive infinity. So now we're applying the comparison test, the inequality version. Okay. So the most important thing there, in my opinion, is trying to work out what are you trying to show this converges or are you trying to show it diverges? And what you can do is just look at it and go, well, I think it's gonna diverge, and that way you get the inequalities in the right spot. Okay. But sometimes you'll make a mistake and you'll go, oh, actually that's not going to work, and then you need to go and do the other thing. How would? Oh, maybe Jovanka. You might be able to do it. You do have x squared minus x though instead of just x. So you might be able to do it using like a substitution. So I think what Jovanka is saying is you got something like this, and then you can go, well, that's kind of like a p integral right there because you've got the power 1/3. But what about this? Maybe you need to make a substitution. I don't think you can use the p test straight on that because p tests are designed for these sorts of things. Okay, whereas here you've got x squared minus x. Does that make sense, Jovanka? Okay, cool. All right, so if you have any more questions, keep them coming. Keep them coming. Let's have a look at another one. All right, so this is another one. Let's look at part C. So this is slightly more challenging because it's not like a polynomial like x squared or x cubed or something. So do we know any inequalities for the natural logarithm of x? Well, the answer is yes. How can we use that to help us? I thought there was a delivery. So let's have a look. So this is 22C. Yeah. Okay, so let me just share my document camera with you. All right, so the integral of 1 on log x. Okay, so the question is, they're asking us to use a comparison test. What do we know? Okay, so we know that the natural log of x is less than that for x between, say, 2 and off to positive infinity. Okay, so we can divide there and we get that. And so when we integrate this, this is going off to positive infinity because it's, again, it's a p test, p integral. So this and this is a divergent, goes off to positive infinity, a p integral, right? So with p equal 1. So this must go to infinity, it pushes that one off to infinity. So it's got to diverge. So by the comparison test, I also converges. Diverges. Okay. So with that one, it wasn't quite clear what was happening, but we sort of worked it out by playing around with these inequalities and saying, oh, okay, well, that diverges, so the integral of that's got to also diverge. Yeah? So are there any questions so far? Because we're about halfway through. And is there anything you'd like me to go over or talk about again? The next thing we're going to talk about is the limit form of the comparison test. Okay. So the limit form of the comparison test is very useful, and as like it involves limits. Okay. So let's have a look at that. Okay. So who can tell me 23 part A? Let's have a little, let's play a game, okay? All right, let's play a game. If you don't know, just guess. 23A converges. Yes or no? If you don't know, just guess. Have a guess. Ethan, what do you think? Oh, Ethan thinks yes. Andrew, what do you think, buddy? Does it converge or does it diverge? What about you, Borgia? Aziz, what do you think? Rami, do you agree? Does it converge or does it diverge, you think? If you don't know, just guess. Just have a guess. If you don't know, then just guess. Carl, what do you think? Yes or no? Oh, hang on a second. I'll be back in 1 minute. All right, I'm back. Sorry. All right, so 20 people said yes. 3 people said no, and 5 people are asleep. So the thing I look at, I say, okay, power 1 up here, power 3 down here. It's a bit like 1 on x squared, which converges. Okay, so that's the way I would do it. Okay, so let's have a look at how we might do this on paper. All right, so we've got, this is 23a. So consider I equals this integral here. Okay, and if you see, well, the -1 isn't going to change much, so x over x squared, x cubed will give you something like 1 on x squared. Okay, so let f of x, so how does this limit form of the comparison test work? This is how you do it. I'm going to choose, in this case, a p integral that helps, that is related to this one, right? So I'm going to choose g of x to be 1 on x squared. Okay, so how did I do that? The squared comes from the difference between the 3 and the 1. Okay, that's how I did it, right? Now, we know that this is a convergent p integral with p equals 2. Okay. The other thing we want to check is the limit of this f over g. Okay. If the limit of this ratio is finite, then whatever this new integral does, the original integral must also do. Okay, so it's a bit messy, but it's just a little bit of algebra now. Okay, 1 on x squared. All right, so we've got two fractions. We can multiply by the reciprocal, and then we start simplifying. All right, so who can tell me what is the limit of this going to be? Who can tell me in the chat? What is the limit of this going to be? Maximilian says 1/2. Absolutely correct. Yes, Niharika. Yes. Okay. So the way you can do it, if you want to, is look at the highest power in the denominator and then divide by it. Okay. So that's going to 0 and you'll get 1/2, which is finite. Hence, by the limit form of the comparison test, let's call this J. Since our new integral converges, the original integral also has the same behavior. It also converges. Okay? So that's the idea. You think about it, you go, oh, okay, well, look at the difference between the powers, form a new integral where you know the behavior of the integral, and then check the limit. Okay, if the limit is finite, then whatever this new integral does, the original integral has the same behavior. Okay, so hopefully you're seeing a pattern now. You're seeing a pattern. Let's play another game and see if we can just do these in our head. Okay, I'm not going to do all the working, but we can sort of guess and see if we're correct. Okay, so let me have a little poll here. Okay, so this is 23B. Look at 23B. Let me know your answer. What do you think happens? What do you think happens in 23B? Okay, if you don't know, just have a guess. It's not a test. Leslie, what do you think? It's the last tutorial, so let's all have a go. Have a guess if you don't know. Thank you, Leslie. Todd, what do you think? Oliver, what do you think out there? Carl, Blair, what do you think? If you don't know, just have a guess. Okay, almost everybody's voted. That's great. Andrew, what do you think? Let me know. All right, so 13 people said it diverges, 8 people said it converges. So let's have a look. All right. So let's see what we can do. Yeah, if you look carefully, the highest power in the top is 1. The highest power in the bottom is a squared. So this will kind of behave like 1 on x. Okay, and so 1 on x, the integral of that diverges. So I would think that this one diverges. Okay, so let's have a look, and we can do it on paper and see if we're correct. So this is 23b. Now, the reason why I spend some time talking about it before we actually do it is because it's helpful to know, well, am I trying to show convergence or am I trying to show divergence? I think that's really important because you might just do the wrong thing and then you waste a lot of time. Okay, so I'm going to consider 1 on x. Okay, so this, I'm going to let this be my f of x, and I'm going to choose this, right? And we know that the integral of this diverges. Okay, it's a divergent p integral. So let's look at the ratio of f on g and the limit and see if it's finite. Okay, so let me put that up here. Okay, so we've got a bit of a mess, but I can take the x up there and then simplify. Okay, and who can tell me what is the limit of this going to be? Who can tell me on the chart? Who can tell me? Niharika, absolutely. She's finite. So it's 2, it's finite. The limit exists, of course, it's 2. And so whatever the new integral does, the original integral must also do. So by the limit form of the comparison test, let's call that J. Since J diverges, our I also diverges. Okay. Why is it 2, Carl? That is an excellent question. Let's have a look. So divide the top and the bottom by x squared. Okay, divide the top by x squared, the bottom by x squared. This goes to 0, this goes to 0. Yeah. So divide by x squared, the highest power in the denominator. Right? Divide, yeah, x squared, exactly. Exactly. So that's some of the justification for it. So that's a good question, Carl. No problem. 没问题, no problem. Okay. Okay, so Yeah, so that's the improper integrals. Let's do one more, and then we can just do this one sort of off the top of our heads. Okay. All right. So let's look at C. Okay. So this is going to be the last poll for this tutorial. So let me do a poll. So this is 23C. Does it converge or diverge? Uh, so it's the very last question we're going to do. So sad, so sad. So just by looking at it, do you think it converges or do you think it diverges? This is the question. Well, it's quite equal at the moment. If you haven't voted, vote soon. Aiden and Carl think it convert. Oh, the votes are changing now. Come on, last one. If you don't know, just have a guess. Just have a guess. It's the last one. Thank you, Andrew. It's the very last one. Okay, so 15 people said it converges. 6 people said it diverges. Let's have a look. 6 people are still asleep. So let's look at the highest power, x to the power 6, and you have a square root. So it'll be something like x to the power 3. Okay, so I would think it converges. Converges. All right, so I won't do a full solution, but I'll just get the basics out. So, yeah. Okay, so the negative one is not going to affect it when x is large. And so I would compare with x cubed. Okay, so you know, like your g of x here is going to be 1 on x cubed. Okay, and this is a convergent p integral. Okay, so this will, you know, so f of x is going to be 1 on this. Okay, so when you take the limit of this divided by this, you will get a finite limit, and yeah, apply the comparison, the limit form, sorry, the limit form of the comparison theorem. Yes, you might be able to do that, Carl. 1 on x to the power 6. So let's have a look. Let's look at Carl's solution. Okay, so let's just think about this. Is if that's that. Okay, so f of x over, so this is Carl. Okay, Professor Carl, I like it. So, okay, let's see what happens. This goes up there. Now, what happens when you take the limit as x approaches infinity? It doesn't help. Okay, so it doesn't help. That choice is not a good choice. You need to think about the square root sign. Okay, but it was a good suggestion, Carl. So this is a better choice because you're sort of, you're looking at this and you're going, oh, well, what's that? Okay. Anyway, Carl, it's good to try things. At least you're trying things. That's a good thing to do. You need to try stuff. Okay. Okay, everybody. Well, this is the final few minutes of our class. A few questions and comments for you. I've really enjoyed this class, and I've enjoyed getting to teach you, and get to see your comments and sometimes people chatting. I hope maybe in the future that I'll get to meet you one day, maybe on the campus here, maybe next year. If you haven't done the course and teacher evaluation, then I put a link in the chat. It's important to get feedback, so let me know your thoughts. And yeah, thanks for coming for the whole of term 3. So it's been great. So I just wanted to say thank you very much. And if anybody has any last questions or comments, I'm going to turn the recording off. So yeah, maybe I'll see you on Thursday.